So for my interactive learning assignment number 3, I'm going to be doing 3 math problems for you. So here's the first one. I've already written it down right here. It's basically the derivative of natural log of 3x over x squared plus 1. Now, this function actually is a composite function, so we're going to have to use the chain rule. And remember, the chain rule states that if you have a function, I'll say f of g of x. The derivative is the derivative of f of g times the derivative of g of x. So in this case, natural log of x is going to be our f of x, and 3x over x squared plus 1 is going to be our g of x. So when we write this, we're going to write the derivative as 1 over 3x over x squared plus 1 times, now as you see, the g of x is actually a fraction, so we're gonna have to use the quotient rule. And the quotient rule I write over here is basically the derivative of the top function, which is 3 of x. So actually I'll write it in the same here. So say we have f of x over g of x. So the derivative is going to be the derivative of the top function, which is f of x. So it's going to be derivative of f of x times g of x minus f of x times g prime of x, derivative of g, over g x squared. So it's the derivative of the top function times the bottom function minus the top function times the derivative of the bottom function over the bottom function squared. So in this case, that our top function is 3x and our bottom function is x squared plus 1. So we're going to have times 3 times x squared plus 1 minus 3x times 2x. So over x squared plus 1 squared. So I'm actually, when you have something over a fraction, it's the same as saying, so in this case we kind of have like a fraction over a fraction over a fraction. So we're going to have to multiply by this reciprocal. So simply 1 over 3x over x squared plus 1 is the same as saying x squared plus 1 over 3x. So we're going to simplify that, and we're also going to simplify this side of the equation right here by distributing the 3 and multiplying this out, and also solving this. So this is equal to x squared plus 1 over 3x times 3x squared plus 3 minus 6x squared over x to the 4th plus 2x squared 2x squared plus 1. So we can actually simplify this even more by going right down here. So it's x squared plus 1 over 3x times, so over here we have 3x squared, say minus 6x squared. So that's going to get times, and since this 3 is actually a positive, I'm going to write this first. So times 3 minus 3x squared over x to the 4th plus 2x squared plus 1. So now I'm going to multiply this out. So basically, I'm actually going to write this as, I'm going to split this up. I'm going to write this as 2 different ones. So it's going to be x squared times 3 minus 3x squared plus 1 times 3 minus 3x squared over 3x times x to the 4th plus 2x squared plus 1. So this is going to equal 3x squared minus 3x to the 4th plus 3 minus 3x squared. Oops, sorry about that. 3x squared over, this here is actually 3x is going to apply to the whole thing. So we have 3x to the 5th plus 6x cubed plus 3x. So this right here essentially is going to be the derivative of natural log of 3x over x squared plus 1. Now for my second problem, it's going to be the integral of 3x 1 plus x squared. As you see, it's very similar to what we had set as our g function in my first equation. So when I do this, when I take the integral here, I have to do some thinking, because as you see, if you take the derivative of this bottom function, you're going to get 2x, and that's 3x. So essentially, this 3x is 3 halves times the derivative of the bottom function. So this is we're going to write this as we're going to write this actually as the integral of, we're going to actually have 3 halves out here outside. Since this is a constant, we can take it out of the integral. So it's 3 halves times dx 1 plus x squared. So this actually makes this equation look much easier. And so we know that since this is dx and this is x squared and this 3 half, we actually know that this is a natural log function, because this makes it, because it's dx. If it was something else up here, we know it wouldn't be the natural log. It would be something. It'd be an exponent. This is natural log. So the integral 3 halves times the integral of dx over 1 plus x squared is equal to 3 halves times the natural log of 1 plus x squared plus c. Now we have to remember, we have to write plus c at the end, because this is an indefinite integral, and when you have an indefinite integral, you're going to have a constant. Either way, you're going to have a constant, but when it's a definite integral, the constant's going to work out when you solve it. But in this case, you're always going to have a constant, so you always need to make sure you put that plus c. Now, for my third and final problem, my problem is going to be the d over dx. So derivative of 2 times 5x plus 1. Now, the general form for this equation is a to the x, where in this case, this x function right here is going to be 5x plus 1, and a is going to be 2. Now, this is a general rule that we learn in physics. I mean, not physics, I'm sorry, calculus. That when you're taking the derivative of a constant to the x, the derivative is going to be the natural log of a times a to the x times the derivative of the x. So in this case, it'd be 1, because it's x. So basically, that's the derivative of a to the x. So in this case, when we have 2 to the 5x plus 1, we know that 5x plus 1 is going to be in place of this x right here, and the 2 is going to be the a. So the derivative of 2 to the 5x plus 1 is the natural log of 2 times 2 to the 5x plus 1 times 5. Times 5. So you can write this as 5 times the natural log of 2 times the 2 to the 5x plus 1. There you go. Now to recap, so we have the derivative of the natural log of 3x over x squared plus 1 is equal to 3x squared minus 3x to the 4th plus 3 minus 3x squared, 3x to the 5th over 3x to the 5th plus 6x to the 3rd plus 3x. I'm sorry, actually I was just looking at this. I can actually simplify this even more. Actually, I have a positive 3x squared over here and a negative 3x squared over here. So this is actually going to be equal to, since in this case, since the 3 is positive and negative 3/4 is negative, so I'll write 3 in the front. So it's going to be equal to 3 minus 3x to the 4th over 3x to the 5th plus 6x to the 3rd plus 3x. There. And that will be our derivative. 3 minus 3x to the 4th over 3x to the 5th plus 6x to the 3rd plus 3x. And so for our second problem, we have the integral of 3x over 1 plus x squared. So the integral of that is 3/2 natural log of 1 plus x squared plus c. And for our last and final problem, we had the derivative of 2 to the 5x plus 1, and that derivative is equal to 5 natural log of 2 times 2 5x plus 1. 2 to the 5x plus 1. Thanks for watching.